Today I'd like to work 3 quick examples to take you through geometric sequences, how to determine a common ratio, find the explicit formula, and then solve for a specific term. In this first example, it asks us to determine if the sequence is geometric. The best way to do this is to first look and see, does it have a common ratio? One thing that you need to know about geometric sequences is if you want to progress from one term to the next, as you are going to the right, you are actually going to be multiplying by a common ratio. So the easiest way to find out if it has a common ratio is to actually pay attention to the definition of the word itself. This implies division. So what we can do is use a backwards division to test. If I take the second term, -8, and I divide it by the first term, 2, I get -4. I can do the same thing with the third term, divide it by the second term, and I also get -4. I would probably go ahead and test this last one also. When I divide -128 by 32, I also get -4. So since the ratio is consistent, this is a geometric sequence. R would be equal to -4. To write an explicit formula for a geometric sequence, we're going to use this rule. A sub n is equal to a sub 1 times r raised to the n-1 power. The only parts of this formula that you're going to fill in are the first term and the ratio. Both of these can be found in what is given to us. The first term is literally the first term in this sequence. We have found r already. Let's plug those in. So our explicit formula will be a sub n is equal to 2 times -4 raised to the n-1 power. We're not going to fill in the n's at this time because we want this to remain a generic formula, something we can use to find any term in the sequence. The problem asks us to find the 8th term. So what we're going to do is everywhere that we see an n, we're going to replace it with an 8. You may want to pull out your calculator at this time. When you're entering this equation into your calculator, I would make the recommendation that you enter it exactly as you see it. Be careful to differentiate between a negative sign and a minus sign. I have 2 times -4, and I'm going to raise that to the 8 minus 1. So the 8th term in this geometric sequence is -32,768. I'd like to do one more of this type of problem. This particular example has fractions in it, and I've chosen this one because I'd like to remind you how to put a fraction into your calculator if you need to use the calculator. We're going to start it the same way. In order to determine if this sequence is geometric, we will first test and see if it does have a common ratio. We'll do this by dividing the terms second divided by first, a backwards motion. So I'm going to take -1 and divide it by -2. That gives me 1/2. I'm going to continue doing this. -1/2 divided by -1. Since I'm dividing by a 1, the value is not going to change. I just need to focus on the signs. A negative divided by a negative is going to become a positive. So my answer is positive 1/2. Let me test this last one. -1/4 divided by -1/2. If you want to do this by hand, you need to change this to a multiplication and use the reciprocal of the second fraction. If you want to put it into your calculator, let me remind you how to do this. You can use alpha y equals enter to enter a fraction into your calculator. Again, since you have a negative sign, make sure you use the negative at the bottom of the calculator. -1 divided by 4. Then I can put divide, and I will do alpha y equals enter to enter my second fraction. -1 divided by 2. My final answer is 1/2. So I can see that I have a consistent ratio. R is equal to 1/2. Now it's time to write our explicit formula. I'm going to fill in the A1 and I'll fill in the R. My first term is -2. My ratio is 1/2 and I'm raising it to the n-1 power. Now, the problem asked me to find the 8th term. So just like I did in the last problem, I'm going to take the 8 and I'll replace each of these n's with that number. Now, if you would like to pull out your calculator, you can go ahead and do so. I'm going to enter -2 times 1/2. So let's use alpha y equals enter again. 1 divided by 2. Don't forget to close your parentheses, and then we'll raise that to the 8-1 power. My final answer, my 8th term, is -1 over 64. In this final example, we have a different set of instructions. We've already been given the explicit formula. They want us to look at this formula, find the common ratio, and the first 5 terms. The great news is they've already given us 2 of our answers. We know that this formula tells me the first term and it tells me the ratio. So, since they wanted me to find the common ratio, that'll be the first answer I write down. R is equal to 1/5. As far as the first 5 terms, term number 1 is given, -375. So there's 2 ways that you can go about finding the other 4 terms. You could take the number of the term and you could actually plug it in for every n that you see in the problem. Then you could use your calculator to find out what the answer is. That's option number 1. Or you can remember the rule that I told you before. If you are progressing forward in a sequence, you can do that by multiplying each term by the given ratio. Since I know that that ratio is 1 over 5, I can multiply each term by 1/5 and I'll get the answer. So if I take -375 and I multiply by 1/5, I can see that the answer is -75. If I want to go to the next term, I'll take term 2, -75, and I'll multiply it by 1/5. That gives me -15. I'll do the same thing to get term number 4. I will take term 3, -15, multiply by 1/5, and I get -3. Finally, to get term 5, I will take -3, multiply by 1/5, and my final answer is -3 over 5.